Hello, 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 and welcome tonight's stream to another Odin Wednesday. Yes, today is Wednesday, the day of our Lord. So, right, we are going to have to do as everyone knows, is post this to the correct places so that people know what is happening, such as that. This particular place, yes, that's one place. Another place that I need to post is to this place. We need to post to... Yes, clearly you're not happening. It's this to go to this place. We're going to have to post to that place. That place. Hello. And any other places that people can think of. So I'm going to wait till people come on the stream. Good evening. How is everybody doing? Right, a few more people are popping up. This is good. This is very good news. How is everybody doing in the wonderful land of, well, the internets? That's a place. That's a land. Right, today's stream, I still haven't planned what I'm going to be doing, but I probably have got an idea, at least. One of them is going to be a bit of a discussion, talk about stuff. I got two things we'll discuss, and then one problem is a bit of programming as well. Okay, so I'm going to just wait till some more people come, because it looks like they are coming soon, so just wait one more minute and that's it. Okie dokes, doing great. Welcome. Hello, Ben. How you doing? Don't worry, debug information is going to come soon. I'm going to start working on it soon, is what I mean. Because of other good news, if people did not know. Which I'll tell in a minute, don't worry. So, how is everybody doing? Should we have some music on tonight, or just keep it my voice, nothing else but my voice? Is my voice probably good enough? I guess. Maybe, I don't know. It's a weird thing at the end of the day, hearing your own voice and stuff. I'm looking for something anyway at the moment. Right. One thing I wanted to discuss to begin with was. Fun fact, I'm starting my own company. That's one thing. So that's one I've got my own company started now. So I'll be working for myself soon. That'd be good news, which means I'll have some more time to work on Odin as well, and projects in Odin, related to Odin, of course, such as the Django Effects people who will be working on the Embergen, which is a very good real-time gas and fire simulation program used in games and films and TV shows and stuff like that. Anywhere that want real-time things that look good. And again, all of their the tool is written in Odin, and they do utilize the GPU a lot for everything. That's one thing. So Odin's good in that regard. What else am I doing? So also that means I'm gonna have some more time working on Odin. So if anything's going on, yeah. And yes, they'll be contracting through my company. That is correct. I do have a name for it. I'm not going to say it yet, because I want to get a nice little website done and everything like that. So let's just get that sorted first. What else is there? Yeah, so that's the good thing. And yeah, I'm going self-employed. It also means I've got other things I'm going to have to do, but not yet. I won't announce them. Hint, hint, nudge, nudge. No. I'm not starting my own computer brewery yet. No. Again, if I was going to start a brewery, I'd do it in a few years' time, when I've got the skills, I think, because I don't think I'm good enough yet as a brewer to start my own brewery. And also I'd want some extra capital just in case, because it's not that cheap to start a brewery. Because you've got the equipment to buy, all the stuff, and then you've got all the licensing, the taxes. Oh God, it's not cheap to start up. And then you've got to make sure you've got the place and it's in a good location and all that. It's a lot more than just starting a software company, which you can just do at your own office. It's a very low entry barrier for that. Well, I've got to buy the computers, which means a bit of expense, but not much. The other thing I wanted to talk about was, did people watch, or haven't watched yet, is Jonathan Blow did a stream last night. I watched the stream, I didn't watch all the Q&A at the end. He was doing on pretty much... it's a very good stream to watch. It's on Twitch at the moment. I don't think he's uploaded it to YouTube yet. So it's on his Twitch. It's Twitch TV at Naysayer88. I think it's also John is streaming live at the moment as well, by the looks of it. Oh, he is. That's good to know. But you want to be watching me, not John. No, yeah, it's much better. But yeah, his stream was a very good stream actually. I recommend probably watching it. The title of his stream was, let me see, it was a lecture he did. It was a talk, video games and the future of education. Yeah, so he was thinking of video games as a very good medium for educating people by doing things. Video games are not necessarily, and this is the gist of it, different mediums have different ways of conveying information differently and more effectively. For instance, books are very good at doing very precise things and telling stories in a very precise manner. While a video game is not necessarily, not very good at telling stories necessarily in traditional sense, and they're usually more a good way of getting people to do things and learn things that way. But yeah, it's a very good talk. I recommend people watching it. It's a very evolutionary thinking wise, which I completely agree with in that regard. So I do have some minor criticism here. They're just so minor, it's not even a problem. One of them's like, yeah, I do think games are good at telling stories, but they're more you enact the story, and the stories are very simple stories, and then the stories are not usually the main thing you're playing it for. So yeah, I probably agree with him in that case. Then it's just different phrasing. And what was my other disagreement? It wasn't even big. It was like most of it's a wonderful talk. I recommend people watching it. But yeah, he's also John's stream at the moment. But of course, Odin Wednesdays, man. Odin Wednesdays. So the other thing I wanted to talk about, which I can just show the screen now, actually, I've been experimenting in Odin and trying to implement channels. These are CSP style channels in Odin, using just Odin itself. So CSP is communicating sequential processes, which is an algebra for doing like concurrency in programming languages. And it was developed by Tony Hoare in 1978, if I remember correctly, the date. And it's very interesting anyway. I've been reading the papers and reading the book, and I'm kind of fascinated by it all, and kind of how simple it is as well. Because at the end of the day, this is how I'm thinking about it, is that a channel is effectively like a pipe. Like, you know, in like Unix, you've got pipes and you can pipe things together. And they effectively act as like, that's what a channel is. Channels, you have different processes. Processes is a general term, by the way. It means like a thread or a coroutine, or it just means another process. It's just a very general term for like a sequential step things. So if you were thinking of a program as an entire directed acyclic graph, you could think of a process as just a linear chain of different things you could go through, and that's kind of a separate process that doesn't interact with anything else. Best way of thinking about it. So the way I've been doing it is just through threads at the moment. So a channel, essentially, is if I actually look at the raw channel, which I came up with here, what you've got here is a queue. This is just a queue, plus a condition, plus a mutex. Yep, that's what it is. So this is actually a ring buffer. It's a queue. I'm using it as a queue, ring buffer queue, but it's a queue. And yeah, with a mutex and condition, because the condition is there to signal and wait for when something happens. So you're signaling when you've sent information, and then you're waiting for it when you're trying to receive the information. And when you're waiting for it and nothing's happening, you're going to block. And when you're trying to send, but the queue is full at the moment, then it's going to block as well until the queue is empty, or it's been, and then the other end like received from it. That's pretty much what it is. It's a very, very clever idea. It's a very simple idea as well, and it's a very emergent data structure, because a lot of the time when I'm programming like concurrent data structures and such, this kind of pattern pops up a lot of time. And even though I had never thought of it this way, it's now I'm thinking, oh wait, queues, use them all the time in doing parallelism, concurrency, queues everywhere, queues. And then you also conditions as well, mutexes, I don't know, mutexes sounds cooler, but it's probably mutexes. Mutual exclusion lock. Yeah. When you're just using these things and you're using that, you use the condition to signal and wait. And it's a very nice little thing to do. But again, I use these a lot together, and effectively you've just got a single unit, which is the channel. Now, my other little looks into programming as well was looking at different concurrency models. So it was the actor model and like futures and promises. And my conclusions were the actor model is pretty much the dual of channels and CSPHC. It's the dual in like it's like the opposite. Everything's kind of reflection of it. But I also found that the actor model itself, the reason why it's very popular in OOP languages is because of its OOPy nature. So as I have a definition of OOP before, it's the orientation around objects. Objects are values with agency. Values with behavior which implies agency. And an agent, at the end of the day, is an actor with agency. So I know it sounds like a bit weird to get there. It's like leaps and bounds, but no, it's simple. Like, it's basing around actors. So it fits very well into the object-oriented model. Now, the CSP style does fit in very nicely with the procedural model. Like, you can just integrate it to procedural programming, and then there's virtually no problem. Like, you can just add it in like I'm doing now. That's why like Go chose one of those approaches, other than it being Rob Pike. Yeah, but it does add in very well. And it's very interesting that that's the case. So for me, the channel seems to be more of a more useful primitive than just the general mutex and the condition, because you can actually do it. So yeah, it's kind of it is interesting that you can just plop it into a procedural language, an imperative language, and it will just work like that. Which is I'm just saying, because it is essentially just a message queue with a mutex and a condition. I've also got ways of saying if it's closed, and this ready is just a flag. It's just an extra Boolean like atomic flag. That's all that is. And the memory allocator is this memory, because what I do is this pointer to the data, I can actually probably just remove it, because the data pointer is at the end for the type. I just have data here because then it doesn't mean I have to find out where the end is and make sure the alignment's correct. I could just have this stored as an offset and be done. Like, it could just be a byte and be done. I could actually do that, to be honest with you. Let's do that. Data offset U16. Yep, let's just do that. That sounds like data offset. Oh look, I've got a data offset there. Let's call that a U16 for the data offset. And now it's not going to compile. Wait a minute. I'm just going to build this into release mode. Yes, I'm insane, don't worry. Come on. Great. Okay, now it's building really, very fast. So we've got the data. So that's going to be C, which is the pointer itself, to the data offset, which is another uint pointer, and then to the data. It's going to also crash here because there we go, and it's still going to work. So now I have just cleaned up that code for the raw channel, just making it smaller, because now I'm not using as much information as I necessarily need to, not wasting as much. Now I could probably make this even smaller, like the element size. To be honest with you, I do not think it's going to be any more ever than like a U32. So I'm just going to I'm going to put an assert here. Element size of int of the element size equals the element size. Yeah? I'm just going to do that. And then we're going to do that. Uint pointer there, and you want another. Oh no, it's been int. Whoops. Int. The only reason I'm doing that is just to minimize the size of that entire data structure. So, channels in this context are the CSP style ones, communicating sequential processes. So just to mean what I mean, it's like Go channels, in fact. So let me just find the Go example channels. Actually, I could do a walkthrough here for a channel. I've got my own little demos I've been doing. So here's probably, actually, no, it's a little bit complicated. Let's try and look for, which one was my simple example? Yeah, this one is in line, is the best way of putting it. So this is a nice little basic example. Oh, actually, this is buffered one. It's not basic at all. These are all my tests. I need to find a decent one. I'll just use the Lucas numbers. They're like a bit nicer. So a channel is like Go channels. So if I go to let's let Golang channels and get the tour of their concurrency stuff, which is on, here we go. So Go's thing here. So Go has different constructs in Go, and there are actually 3 basic primitives to actually allow for CSP. The 3 primitives they have are Go routines, which is their processes. So this is just pretty much green threads with a better name, pretty much. Go also has channels, which you can send information through these channels, and it's a way of communicating across these channels. So for instance, this is a good example here, and it runs and such. So you have sending some work to this thing, and when it's done, the work is then sent to the channel, which is made here. And then what you're doing is blocking until you've received something and then storing it. So this will block until this is done, and then when it is done, it returns. Simple enough. That's what a channel is. Very, very basic. Nothing complicated about it. Buffered channels are slightly different. So a buffered channel will not block unless it's complete. The queue that it's now got back, the buffered data, is blocked. And it means, okay, we don't want to do this. This is very, very simple. So we got 1, 2, 3, and 4, and this means it's not blocked. But if I did a channel 5, if I just run this, it's fine. So what they've done is closed it as well, whoever wrote this, and you're going through it. You can also iterate through it, and then when you close it, you're just plopping them off. Okay, done. Very, very simple, nothing complicated. Now what I'm going to do here is put 5 in here, and it will block, and it'll say deadlock. Whoops, deadlocked. And that's because it's now blocking, because the entire queue's full, and because it's full, it's waiting until the other side is got some data so it can actually move it across. Simple enough. Range and close is slightly, so range just iterates them across, iterates across it. And close, usually you want the senders to close things, not the receivers. That's a good habit to do. Like, yeah, it tells you here. You should, yes, there is a big difference between unbuffered length 0 and 1, and it's because it's very simple to actually think. I can actually draw it. Let me just get my graphics tablet. I need to get a better one. I also need that for another reason anyway. But the one I have is a bit, yeah, it does the job. It's just not that great. Let's get Milton up. So I'll explain it. It's very, very simple. So let's do a new Milton canvas. Oops, no. Like so. We want a bit of yellow. Okay, so lovely jubbly. Here we go. So for an unbuffered queue, so we've got capacity 0. We are going to have, let's say we've got this little sender. So we're going to call this sender. And it's going to pass a message across. So I'm going to call this message across to the receiver. Yeah? Yep, simple enough, nothing complicated. Now that's what channel does at the end of the day. Now if there's no information, if this sender, it'll go send the data, there's no like buffer to do it, it'll just wait, it'll block on this side until the receiver picks it up and goes, yep, I can take it off for you, great. Now, if that's the case, if there was a buffer, so we've got sender, and then we've now got a queue, and if we've got a queue, we'll say queue of 2, and then receiver, it can then keep, let's go to a different color, it can go, okay, we're going to send some stuff for tick, done. We're going to send another message, tick, done. And then it's like, oh, we need to send another message, but it's full, so we're going to block until the receiver comes along, and then the receiver goes, right, we're going to take that one. Actually, we'll do it the other way around, technically. I'm going to do this one, and now I'm going to take this one, and now it's unblocked. I'm going to take the one you just sent me. Does that make sense? So for the singular buffered case, so just a single queue, when this gets filled, then it blocks until this comes along. Yeah? That's the difference between a buffered and unbuffered. It is literally how big is this queue, because if it's 0, it blocks straight away, and until the queue is filled up. Now, I haven't implemented, nor do I want to actually have an infinite length queue where it never blocks. Now, the reason for this is that because of numerous reasons, but it's like you don't really want it. Can a buffered channel have a buffered size of 0? Yeah, so I'll be very careful. So there's a capacity. This has a capacity of 2. This is capacity is 2, but the length of this at the moment is 0. There's nothing in it. So a buffered channel could be empty. And if it is empty, when you add something onto the queue, it's fine. Like, it's not going to block. Like, this side is not blocked. So they're used for when you need to communicate information between threads, pretty much. That's the whole point of a channel. Many people, normally you would go, oh, you'd have a condition variable to do this, and then you'd send the message. You'd have to send a sort of variable where you can read it from with a mutex lock. And the thing is, it's like you're doing that. That's effectively what a channel is, an unbuffered channel at least. And if you want a queue with a message queue, couple it with it, you've now got a buffered channel. So it's a very simple construct, but it's just an emergent data structure that happens from many basic other primitives. So that's a nice little basic example of it. Now, the third primitive that Go actually has is the select statement. So in CSP speak, this is a particular kind of choice. The old-fashioned was an internal choice, and this is a non-deterministic choice. And a non-deterministic means if any of them are valid, it'll just choose one randomly. Okay, so the reason why I'm looking at Go is because it's one of the only languages that did it. It's also popular at the moment, so it's easier to do check. And I have used Go channels before numerous times. I've just never realised, oh wait, that's what they are fundamentally. My mental model wasn't that previously. It's very weird. But it's like, okay, that makes sense. But I've been interested in, like, okay, people always ask me, and I get this about 4 times a month, which is quite a lot, to be honest with you, asking, does Odin have any like concurrency features built in or parallelism features built in to the language? And I always say no, but the standard library does. And they're like, oh, why not? And I'm like, usually because you need some form of automatic memory management to do it correctly. And they go, oh, okay. Usually it's very easy to answer that. Like, okay, that makes perfect sense. But it's like, that is the reason why. So theoretically, you could do a channel in Odin and have it as a default type. Like, you could have like the dynamic array, and there wouldn't be much of an issue because it would be still use the context allocator. You'd still have to delete it manually, and you could get all these wonderful things. But my issue as to why I would never add it into the core language itself is because most language systems don't support it. As in, most languages don't actually have, platforms, not most platforms, some platforms I should say, some platforms do not have, what's the best word for it, like threads and stuff, or multiple processes, so you'd have to mimic them, and if you were baking that into language, then your entire runtime is going to get very complicated, and if you want to actually go to embedded systems, oh, good luck with that. So someone says, next Go interfaces. No, I'm not going to add Go interfaces, because Go interfaces do actually kind of require garbage collection. They're very interesting, but I also said day one, I'm never adding methods into Odin. And that's not like from an ideological standpoint. It's just because you don't need them. It's very interesting. Like, there are some very valid use cases for Go interfaces, like, oh, good God, IO Reader and IO Write and all that stuff. They're wonderful interfaces. It's pretty much the only interfaces I actually even use in Go, to be honest with you. Because you just sometimes, that's the only time I actually ever want, like, OOP vtables, usually like a generic one. Like, not just like a special case, but a very generic one is like, oh, I want a stream of data, like a reader, a writer, a read writer. That's kind of what I want. It's very, it sounds obvious, but it's like, yeah, but that's the time when you do want something a bit like more generic interface, because unfortunately that's how operating systems work as well. Not unfortunately, but that's just how, well, the world works, isn't it? So, does that make sense? Yeah, Go interfaces are a way to get structural typing into Go. It's a much better way of doing OOP, in my opinion. It's best, even if you call it OOP. It is the best way of doing things because it's implicit, and it's also you can do it on any data type. It doesn't even have to be a record. You can do it on an int if you wanted, your own integer, and have your own methods on it. It's pretty cool, but it is more of a saying this is the interface for the thing that I want and be done. So this is the select statement. So the select statement is a way of doing a choice. Like, okay, read from both of these. If they can either of them receive, randomly choose between each of them. If none of them can receive, block until you can. Now this thing is what I actually want to actually get working, because the way I've actually written how the channels work in Odin at the moment, I could not do it and block. It's because I'm just using a condition variable, and technically what I require is a futex, which is a fast user space mutex, not a condition variable. And the reason why I need that is plainly, well, not plainly, but because I'm trying to think of the best way of putting it. The reason why I want that is because you need a way of actually waiting on multiple mutexes, multiple channels at once. And the way that condition variables work, especially in Windows, is you cannot do that, because condition variables are user space, and I want the equivalent of wait for multiple objects call you do in Win32, but it doesn't exist for the condition variables, because they're not actual event objects, so it's a bit useless. So I need a futex, which is effectively what I want. Our futexes are really, really simple and also really, really small. They can be just a single byte, if I can remember. Well, not a byte, but they can be like 4 bytes in size, so it's very small. And a futex is effectively like a semaphore. Well, it's a semaphore which has a maximum count of 1-ish. I know on Linux they go like crazy, but let's just go there. So let's try and implement this. And on Win32, with the Raymond Chen's help, I've got his blog post here. Look, we need the wait on address and operation. That's what we need to do, and that's how it's going to work. So you can have wait on address is better than a futex, which is effectively this can be a single byte rather than the other approach. But this is what I want, because look, it's limited to a single process. I think that's what I want. Yeah, because I don't want to go across multiple processes. That's correct. Yep. In this case, it means the application process. I know, really confusing things. It waits for a value to change. That's correct. I want to wait on the wakers. Yeah. Acts like whatever you want. Yeah, I just want it to act like that. So you say it requires automatic. Okay, you mentioned that concurrency features in a language often need automatic memory manager, but is that true of channels and selects? Channels, most definitely. Selects, no, but Go routines, yes. So selects are really dumb, because once you've got the channels, selects, you can just work. It's just a function call effectively, and a switch statement put together. There's nothing really fancy about them. I'll show them how I was going to implement them in Odin, which is just you have a function call which says, okay, select on these receives, and I make this also a default with blocking, or you may have a non-blocking case as well. And then it will give you an index. Maybe it will give you the channel which you can compare. I haven't figured out how to do this yet correctly. And then you can do an index of the one you passed into it. It's just going to be validated array, and they'll do the case for you. Very simple. So it'll be a little bit bulky, but it will do the job. Channels, as you can tell here, unbuffered channels, you could probably get away with them, but they'd be very bulky and you couldn't pass them around easily, because I wanted a pointer. So because it's a pointer internally, you kind of want to do it. So I need a way of implementing futexes effectively with the wait on address, and I need to experiment with this a little bit, pretty much. So we have wait on address, and we also have wake by address single and awake address all. So the single is the signal, and the address that's all is the broadcast, or the notify and notify all, whichever you want to call it. The address thing, I only store a byte in there. It's going to be as small as a byte. That's what's so wonderful about this, and it's built into the operating system. I think Linux does it as well. I think Mac does it as well, which means you can keep the data structure of this raw channel as small as you can get it, if necessary. Yeah, you can get it as small as you can. Because at the moment, the thing that's bulking it up is this. But yeah, you need the data at the end, because there's extra data at the end here, which is what the data offset sets. And I'm trying to think this through, yeah. I just want to minimize it. So you need to allocate as a pointer, because otherwise you do as a big data structure, it's not helpful. And then Go routines would require automatic memory management, because you have to manage all those different like fibers and threads and all that lot. It goes a bit crazy. So yeah, I don't want to have it. It's always been the case we have to have it. So one of the things I was also talking about, I was really, really interested in. Whoops, daisy. I just clicked the wrong button. Never the most helpful thing in the world, clicking the wrong button, as you probably well know, are futures and promises. Now, I accidentally discovered last night that a future and promises, effectively, you can implement them with channels. They're a channel plus a Go routine. And I didn't find out until earlier today. This is a well-known fact. Futures can be implemented using channels. A future is a one-element channel, and a promise is a process that sends the channel fulfilling the future. I did not realise this. I mean, it's obvious now that I know it, but it's like, yeah. But to me, I think futures are actually pretty crap as a concept. And I know it sounds silly. Let's see, what do you mean the crap? It's like, well, they are the same as like a channel, pretty much. A channel and a channel and a like a process way, like some way of doing like a thread. We'll just say thread and channel. Just keep it simple so people don't get confused. But the thing is, I just don't see the point of having a future and promise as the foundations of a language. Like those two make much more sense to me than these as a thing, because those require effectively the other two to begin with, or some form of it at least. So in my opinion, it's a bit, if you know what I mean. Hopefully that makes sense. So that's what I'm trying to see if I can do. If I can implement a futex with all my little demos I've got here. I also added a wait group earlier, which is just a counter, mutex, and a condition. So what a wait group is for is you're trying to join multiple different processes together. And I just did loads of threads, so let's do 10. You can start multiple and then you queue them, then they finish. All you're doing is in the stage is you add multiple things to your wait group. So I could just put like the number 10 here, by the way, and be done. It doesn't make a difference. And then start it, and when the thing is done, it's going to say it's done, and then we're waiting until they're all done. So when the wait group counter goes down to 0, it then unblocks itself. That's the general idea behind this thing. And the thing is, it always seems to be the case every time I make a wait group. This is actually called a monitor. It's another Tony Hawk invention as well. Monitor is how pretty much everyone uses a condition variable at the end of the day anyway. You have mutex with the condition variable and pretty much inside of a loop. And yeah, and you're just waiting for the counter to go down to 0, effectively. And I think this maybe should be a loop rather than anything else, but no, it shouldn't be a loop. That's correct. That is correct logic. Because when it's done, it's going to broadcast to all of the threads and then bang, magic. That's how it works. It's very simple, so that's it. So any thoughts on Zig's non-profit? Yes, so for people who don't know, Andrew Kelly has now started his own non-profit now for the Zig language. So it's the Zig Software Foundation. So congratulations on starting the new non-profit to him, and I wish him the best of luck. There are many problems when starting a non-profit, of course. Again, you can have many different issues here and there, but good luck to him trying to start it, and hope for the best, to be honest with you. Again, my main opinion is I'm not a big fan of non-profits in general, just because they have a lot of different weird and different incentives to kind of like a for-profit company would, and they can sometimes make it harder to manage. Sometimes, not always, but it's fine. So yeah, just different things like that. So good on him. And again, people check out the Zig language. I know I'm the creator of the Odin language, but I'm like, yeah, I recommend people use the languages. Sounds like I'm very bad at selling my own language here, aren't I? But no, the main reason is because I think languages are tools, and I want people to use the best tools that they can get. So try all the tools you can and see what happens. Seriously, I mean, try it. You can try Zig, you can try Odin, you can try Nim, you can try Rust, try Go, try C, try Pascal, try any old language you want, Swift, Objective-C, use whatever language is best for the tool, the problem at hand, because languages are just tools. So I highly recommend all of them, and just use them. Okay, any other questions? It's quite a bit busy tonight. Right, so I want to work, and I will just get the Win32 stuff here. Let's just work on getting, I'm moving my graphics tab out of the way for the time being, these new things, what they called, it was the wait on address stuff. Thank you, Raymond Chen, you always know how to make you happy. So, wait on address, I'm going to guess, is in kernel 32. No, it's not. It's in the synchronization lib, isn't it? Yeah, so we have foreign import. That's on system. Oops, in the system, of course, because you have to know where the search path is. Synchronization. We can now put synchronization in there, and then we can create all the new ones. So we have wait on address, and it's going to be an address raw point. This is just for the time being. It's just win32 p void address. No, compare. I'm going to write it in the same style as it is there. Compare address win32 p void address size, that's a win32 size underscore t, dw milliseconds, that's a win32 d word, and then you have a win32 bool. So what I can do here is, instead of just writing it here, I'm just going to add it to the new, which I've been adding it in the sys windows. We're getting rid of win32, and I'm going to call this the synchronization.odin package. What package is it? In sys windows, yeah. Sys windows, and we can probably just move this to here. We can then get rid of all the stuff like that. So we've now got wait on address. We can then wake by address single, wake by address single, and that's just a single address with no return. Default calling convention. In this case, it's just C. And then we have single, which is all. Oops. Like that. Now, any other functions which are part of this sync API that I want to add in. Now, interestingly, those are part of the synchronization lib rather than kernel 32. That is interesting, actually. That is actually very interesting. Hello, Sherlock. How you doing? Wrong old people here. Yeah, that seems to be all I actually require. So if that is actually all I require, what I'm going to do is see if it works the way that I expect. So this is going to be the weight value. I'm just going to use an U32 for the time being. Yeah. It's going all right. It's going all right. Thank you. We're going to do what I think makes sense here for the time being. So we've got a weight value, and the weight we're going to compare it to be. It's going to be. Again, I can't remember how to use this because I've never actually used it, to be honest with you. But I know this should work. I only care about a single process because, especially for channels, they're not meant to communicate more. They're not actually pipes. If you're using pipes, you should be using pipes. Oh, that's nice. Right. Any other questions? So, how the heck should I do this? Because effectively, you want to wait for value by address, and you want to pretty much. Because you're effectively making another monitor at the end of the day, aren't you, for this thing, yeah? So I'm just going to make sure I understand what's going on. So we're going to have another thread thing. So thread run proc in here. I'm going to put time sleep, let's say 1 second. And then we're going to single that thread. So wait value. So that's the address that we are signaling to, of course. It's just any point. It doesn't make a difference. Makes sense. We are then going to for captured value 32 and this is going to be the value that I want to send, effectively, if that makes any sense. So this is going to be the weight value while it doesn't equal 0. Yeah. Is that right? Yeah. While it doesn't equal 0. Let's just try that. I'm going to wait. I don't know if this will work. So what I'm going to do to make sure that if I cock something up, OS exit 1, failure. This is always a good thing to have, actually, if you're doing concurrency stuff. Just have something that runs and then just fails after a certain amount of time. It's a nice little idiom I've got. Weight value captured value, size of value, and then win32 infinite. So win32 there. And then what I'm going to do, weight value We're going to wait. We're then just going to print success afterwards. I don't know if this will work. It's going to say me p void is not defined. Is it not, actually? I'm actually surprised. LP void is, but p void isn't. Well, it is now. Wait value, not just value. Yeah, that didn't work. So, because I think the problem here with the we could try it like this, and then it's a success. So it just does it go straight to success? So I don't want it to. Signal. Well, it's not a single signal. Yeah, this never gets called because I don't think. Yeah, so it does signal and then it fails. So I'm not using this correctly. But the question is, how do I meant to use it? I'm doing this all wrong, and people can say, "You're an idiot, Bill. This is silly. Why can't you do it?" That's technical terms, isn't it? I don't realise. No, I mean, at least it's resolving correctly, which is a good thing. Means it's actually found. Anybody know what to do? Because I literally have never done this before. Just someone recommended me earlier. They say, "Oh, you could do this, couldn't you?" I was like, "Yeah, that would work." Because I know that's exactly what I want as a condition variable. Maybe I'm misunderstanding what the great Raymond Chen is saying. Linux has a synchronization primitive called a futex, which is similar to Windows wait on address in that both let you create a synchronization object out of nothing. Well, okay, let's set that aside some memory. So channels are a way for communicating messages between like threads, pretty much. And they're acting as a synchronization object. There are like two forms: there's unbuffered and buffered. An unbuffered will mean if you send a data, it'll block until it gets received and someone takes it from it in another thread. A buffered one means it'll have a queue. It'll pass on to it, and it'll only block until that queue is full. Pretty much, that's the difference. It's very, very simple. It's a message queue plus a condition variable plus a mutex, effectively. Yeah. So maybe I'm misunderstanding something. Oh, that was funny. If you can get 2 billion threads to wait on a futex, then I'm both impressed and disappointed. Impressed that you were able to get 2 billion threads in the first place, and disappointed that you have a mutex so hot that you managed to get 2 billion threads waiting on it. Oh, that's funny. That is pretty funny, actually. Futexes are wrong. No, it's I don't want. It's not a futex that I want. I want Win32 wait on address, and I just want an example of how to use it because the MSDN is probably not that clever. Well, it is, but it's probably not as clever as I want it to be. No, I don't think it's. Yeah, it's probably not. Well, if you could, that's amazing. I don't think you can. I think many machines will actually just stop after a while. Yeah, I can't remember how this works. Well, I don't know. Okay, there we go. That's how it works. So you need to get it into a state where it's invalid. So I'm going to just... Because to be honest with you, this could just be a bool. And then I'm going to set it to true. And while it's not true, it's set. So now it says success. But have I... Yeah, there we go. So if I set this to false, and that becomes true, we can then do captured value, wait value. Then they both become true on that wait. And do I just do this? Okay, that fails. And yeah, that works. So if I click write the word start here. Yeah, so we have start, signal, and then it says true, true. So effectively what you need to do is... Do I need to do this? No, I need to do both. So effectively this thing can just flip-flop. Oh wow, that's a condition variable that's tiny. It's an entire byte. That's impressive. Because what I'm doing here is, let's get rid of that captured value. Let's call that CV. And then we have another one here, which we're going to wait 2 seconds afterwards. So signal 2, signal 1, and then let's get rid of that. Signal 1 got found, but signal 2 didn't. And that's because it's not the right value I'm looking for anymore. Oh, shit, how would you... What I'm trying to do is effectively turn this into a condition variable. Is effectively what I'm trying to do. Wait, before I even go any further, this is where I'm going to ask. Wake by address all. This is where it doesn't make any sense. Okay, so probably this isn't what I want anyway. Even if it works and it's pretty damn small and pretty cool. Because I'll explain the problem that I have. And it's really... I'll just go to the Go example again. Golang, concurrency. Let's go to the select statement. So in this case here, I'm just going to run it. And then it's quit. You've got a blocking case. So if neither of these are been hit, what happens is it will just block until either of them have. So in Win32, what you would do is wait on multiple objects. You'd say there's 2 in there. There's your objects. You just put the objects in there and do other parameters as well. And then you say, you want to wait on... I think if I remember correctly, wait on multiple objects. Wait for multiple objects. Sorry. And then I'd do infinite. Because what that does is says you wait for all of them, say no, just wait for any of them. And when any of them are done, then we're going to get out of it. because the logic you do for that select statement effectively is if it's blocking, you check to see are any awake. If so, randomly select one. Effectively, else do this, and then randomly select one. That's the logic that you're doing. So you got this randomly select one twice, of course, and that's the logic you're doing for the select statement. And you randomly select one because it makes it a non-deterministic choice rather than deterministic, and it also means the first thing doesn't get hogged all the time, and you actually just it softens the blow and stuff as well. So you do actually have to even a pseudo-random number generator in there. A little bit of fun there, isn't there? So that's quite interesting, but I don't think this is technically what I want. So I know in... So this is actually, no, it probably is what I want. Yeah, but why is it what I want? Because you need a flip-flop value, but you don't want to know... Let's remove that. Yes, so I don't need to set it. So when it does come out, I need to set false to when it's done. Yeah? And then the reason, so I'm going to do... let's just say wait for, I'm going to call that we're going to call that the value, which is a pointer to a boolean. We're going to have this same logic like so, and then we can just say wait value, and then we can have signal, and then we have a signal here, value, and then that's that, because this is technically that's what you let's just make this a bit cleaner by doing that. Oops. It does look a bit cleaner now, it's not as messy. And then that's fine. So we could theoretically do what I've just done here again. Wait for it twice. The second one takes 2 seconds. Signal 1, signal 2, success. Okay, so now I've got condition variable, which is effectively so much simpler than the previous approach, which I was doing for channels, and it will allow me to do the select stuff as well, which is oh yeah. But I'm amazed, like, that is the entire... can anyone see any flaws with that? Because I think I can, because it's the case when this is now true, and then this will be false. So if this is true at this point, because you could theoretically have the case when it comes out and branches and gets to here, you've got this probably that gap that could happen. So you may want to do an atomic intrinsics. This won't do anything, by the way. It really won't. The reason why I'm just doing this is just to be a bit more sane when I'm thinking about it. Because no, you don't need that to be atomic. That's stupid. This is the bit that needs to be atomic. Value false. So also you'd probably want to... Okay, so that works as a condition variable. Great. But if it does work as a condition variable, my question is, how do I wait for multiple? Okay. And the reason why I'm asking for that is we've got going to have multiple weight variables, aren't we? We're going to call this let's call these conditions, but let's have two of them. And then we have condition variable naught and condition variable one naught one. I'm putting an H in there and a W in number one. Okay, so we got that. But I want to wait for any. So wait for any. And I'm going to put conditions bool like so. So I want to wait for any of these to happen. Okay. And then whichever does happen first, rather than the actual one, that should be okay. Because, how do I don't know. I'm trying to think how I'd do this. Anyone got any ideas? I'm trying to effectively trying to do... it doesn't make any sense. It doesn't make any sense. What am I talking about? Let's just say wait. Let's call it wait rather than wait for. Let's do this little value. Because that works as a condition variable, effectively, yeah? So then what I'm going to do is the millisecond tick for tick, 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 tick. And that works as I expect. It's pretty cool. You can go tick, 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 tick. And it's just a ticker. But here's my, and again, this is my question that I've been trying to figure out is, anybody got any ideas? Because I could look at actually how Go implements it. That might be a good idea. I've not really looked. I know I could just look at the runtime and find out. But that just seems like cheating, okay? I know Go uses a few texts as well now. But where is it? And it's under Chan of the, yeah. I could look. Yeah, here we go, Chan. Yeah, it's the same as, yeah, okay, so I've got close enough. Then it has send index and receive index, okay. And then list of receivers and waiters, and then a lock. So does it even have the few texts? What is a lock in this speak? Locks all fields. So how does a lock actually get used? So when you make a chan, you're going to initialize the lock with a lock rank h chan. So let's go for C lock and look at it, all the different examples of it. So you can lock it when you send and unlock it when it's if it's closed, then unlock it and then panic. DQ something off. So my idea, I'm trying to make it very clear to people, is that let's say I've got multiple queues and I want to wait on any of them, and if any of them are available, randomly choose from which ones are available to unblock from, and just receive from it, done, or even send to it if it's available to send to. Either way, just as long as the channel is open, and not open but not unblocking. This is where it goes a little bit weird. Because I'm looking at how it works, and I probably need to look at where this mutex is defined. So I probably just need to ask for help. Because there's the RW mutex, but no, that's not what I was looking for. Type, sorry, you can't see it's on the display. Sorry, I should probably just show it in a minute, but it doesn't matter. I'm not looking for the sync mutex. No, I'm looking for the one in the runtime. I could just probably look at go downloaded and then. This is just me trying to figure it out. I'm like, I've never actually done this before, so this is first for me. No, oh here we go. Oh, I see. Lock rank on. I mean, it shows you how to use it. It doesn't actually say an RW mutex. It's got two mutexes in it. Okay, that's not what I was looking for. Keep looking. It's in. I know it's going to be in the runtime. But where will it be? Okay, it's under runtime 2. There we go. What a very well-named thing. So it has a lock rank struct in it, and then a key. And okay, so this is a mutual exclusion locks in the uncontended case as fast as spin locks. Just a few user-level instructions. But on the contention path, they sleep in the kernel. A zero mutex, sorry, I'm going to just pop it up here for you. A zeroed mutex is unlocked, no need to initialize each lock. Initialization is helpful for stack lock ranking. Okay. Fine, these are all the different things here. They've got a note here. Function value, iFace, this is all the other stuff, isn't it? I got the lock rank struct here, and then it's got a lock rank. What the hell is a lock rank? Isn't it? It's just a lock rank. Yeah, it's got a lock rank struct in there. Where the heck is a lock rank defined? Oh, you got a lock rank on and off. Okay, so you got so there's a lock rank here, and it's just an enum. Oh bloody hell! How many different ranks are there? Oh, this is where you can get different futexes with different parameter types in it, and it's like, oh wow, that's a lot. So the one I actually care about, which looks like in the channel, is the HChan. Okay, HChan, and it's very high up. Okay, so it's a big number. So it's just different types. So you've got a dummy, which is blank, and then all the different ones. Okay, so you'd set that there. Okay. So we have the on and the off doesn't do anything. Oh, so it's disabled by default. So if it is disabled by default, effectively this mutex is just a uint pointer and it's a key. Okay. So the futex-based impl treats it as a uint32. Meanwhile, a semaphore-based implement has a pointer to the m star wait pointer, so whatever m is mutex for a pointer. Used to be a union, but unions break precise garbage collection. Okay, makes sense. So is just a mutex is literally, it's a futex technically, but yeah. Okay. Lock. What was the actual thing? I'm still learning how to do this. So we've got a lock 2. And look at all the different things in here. So we have a semaphore and JavaScript. So the JavaScript one is obviously when you do it in JavaScript. DOI, don't really care. Who uses the semaphore version? Oh, it's for Windows. So we use Windows, Darwin, that. In the case of Linux, they treat it as something else. So let me see what the Windows and the Darwin and all that BSD stuff and the Plan 9 stuff use it as. Okay, so they treat it as a semaphore. Okay. You're getting the GP. This is probably the safe things. So we got this, and then we got locked. What the fuck is? Sorry, what is locked? Locked is 1. Okay, and they've got different values. Why are that those values? I have no idea. So they're doing a compare. Is a compare exchange. What is it? Yeah, so you're comparing it and exchanging it. Okay. So if it equals the old, exchange. If not, just return false. So if this happens, speculative lock, done. Then you're creating a semi-crate. Okay. So then you got an infinite loop effectively here. So you load and do an atomic load of the key pointer, which just be a thing. And then you're checking to see if it's locked. If it's unlocked, try to lock it, else just set back to 1. And then spin is defined here, which is whatever the active spin is. So it's maximum of 4. Okay. If it's more than the spin plus the passive account, which is a lot, you can do an OS yield or on the proc yield, which is slight. I guess that's because of different threads, of course. So I'd do a thread yield in this case to make a difference. And then someone has it. We're going to wait and just do this. So this is a sleep. Okay. So what about the futex approach? Because I would sort of thought it would have been a futex. And yeah, that's a futex to me. There's people make somewhat sound here, so yeah, okay, so I am tired as well, but who cares? That's why you enjoy the streams when you're tired, because then it makes it more enjoyable for viewers somehow. Because reasons, there are reasons to this. Okay, so I've looked at the Go stuff, and I'm going to look at the Go channel stuff as well, because I bet, oh no, Go channel stuff will be under select. Oops, no, select's going to be in a different file entirely, isn't it? Because reasons. You probably just... Oh no, it is different, technically a different construct, isn't it? So, what are the different types of selects? Select Go implements the select statement. CS, it points to the array of the type n cases, and order points to the array of the 2 times the n unit cases, which must be less than... yeah. Both reside on Go's routine stack, regardless of any escaping and select Go. Select Go returns the index of the chosen S case, which is the int, I guess, and Boolean, and also is chosen the receive operator is whether the value is received. So, okay, ignore all this. Replace send cases involving nil channels with a case nil, so logic can assume non-nil channels. So you just give it a non-nil value just in case. Compiler rewrites the selects that simply have constructs of 0, 1 cases plus default into simpler constructs. The only way we can end up with such small n case values here is for larger select in which most channels have been nilled out. So if I remember in Go, if you have a select statement with nothing in it, absolutely nothing, it just blocks forever. Which I can't remember why that's even useful. Is there actually ever a case, or is that just completeness? It blocks forever. So because it blocks, it just does it just yields a CPU compared to a 100% CPU just spinning forever. Okay, with a for loop. Yeah, but is that ever useful, or is it just it is just the same as an empty for loop? Like it just does nothing. Yeah, probably that's the case. Okay. Generate the permutation order, which is just going to be random, of course. Sort the cases itself. That's just a fast random number generate. Oh, okay, randomly. Okay, whatever. Sort the addresses to get the locking order. Okay. And then we're going to go backwards on here to check them. And then lock all the channels involved in the select. Okay. I need to figure out where that selection lock works. Pass one, look for something already waiting. That's fine. I normally check to see if anything was waiting. So we go through all the different cases. If it's a nil case, ignore it. If it's a receive case, handle it. If it's a save case. So receive, check to see if you can actually receive something, or else okay, send, it's fine. Continue for the nil cases. If it's a default case, then yeah, fine. Okay. If there wasn't a default, then unlock and do them. Okay. NQ all the chans, all of them. If it failed, yeah. DQ unsuccessful channels, otherwise they stack up on quiet channels. Record the successful case, if any. We singly link up the pseudo G's in lock order. Okay. This is really complicated logic for a basic primitive type, like a switch statement. You can see what it looks like. For a for statement, you can see what it looks like. And a select statement. This is what a select statement doesn't go. Bloody hell! This is really complicated. Like, really complicated. But I understand what some of, like, I know a lot of this is like, oh, we're just doing checks here, and actually it's a bit simpler, but it's still complicated. Bloody hell. And also heavily using Go too. This is probably like written. This is one thing I've noticed about Go when you read the sort of Go source code, is that what's the best way of putting it? No, that's the wrong way of putting it. Yeah, sorry. The actual like runtime code and the compiler code is very C-like, while the rest of the actual like library isn't very C-like. It's very Odin, Go-like. Not even talking Go-like. There's like a very big difference. Like this is clearly written by C programs if you look at it. Even though they do some cool like fancy things in it, it's very C-like. It's nice to read actually. I'm not complaining. So how is it? Okay. Go is self-hosted, yes. They've been self-hosted for quite a while now. So how does this selection lock work? You've got the channel, so you go through the lock order. You then get the channel. If the channel doesn't equal to C, if it doesn't equal no one doesn't equal C that, then lock it. Then you're locking all the channels, interestingly. Yeah, self-hosting is useful when you get to a certain point, but to be honest with you, it's not. In the early days, it's just masturbatory fun, which I always keep repeating as a phrase. I know, but it is. Okay. Can you see actually how complicated of an idea this is? Because I already implemented a non-blocking select statement. That was really, really easy to do. But the way that I would have done it to make it, then what I'd do is just thread yield and just do an infinite loop, and that's not very good. It's just a bit crap, to be honest with you. It doesn't mean you. But, so I don't like the way that Go does it. It just seems overly complicated. Like I know what they're doing, but it's still overly complicated. Because effectively, maybe I'm not. Maybe people. Maybe this doesn't make any sense. But what I'm trying to do is I'm trying to take advantage of the operating system as much as I can to do stuff for me, so it can be more efficient. It might just be. No. I'm trying to figure out how I do it. Because look, okay, you got event objects in their kernel level objects. And I can already do that, but the problem with them being kernel level is that the OS has a limitation on the number that are available. And if I'm just allocating literally, let's say, thousands of channels, I don't know that's a very good idea. And they're probably very slow to initialize as well. Well, condition variable is a user level thing, so it's a lot faster. Not necessarily faster, but easier to deal with. And also condition variables must have be associated with the lock itself. So, yeah. So it's making me wonder. Yeah, so a conditional variable is the event object, like a keyed event at least, plus the lock object, which is not object value. I'm thinking one more thing about lock value, which is the mutex. So, sorry, this is probably boring a whole lot of people here, me just trying to figure things out. But how do I figure this out? So I could just cheat and implement this with kernel level objects, but it's a question of it is a question, because if you go to the kernel 32 thing here, you create an event, so you can create all the events, security attributes, nil, you'd pretty much do. Manual reset, I'd just keep it blank as hell. And then you can do whatever you need. Oh, this is annoying. So here's a question for the people out there in the internet world. Is there, for what I am trying to achieve, is there any disadvantage to using sorry, it's the wrong way of putting it. Is there any disadvantage to using user level and as kernel level events rather than just using a condition variable? Because that's effectively what I'm trying to ask. Because if that's the case, I can go to synchronize Windows, and I've got this condition variable. Well, I can just write an event as well, can't I? Makes sense. An event struct here, and then event, all it has in there is the handle. It's going to be a handle. Oh, so it has a hard limit of 64. Great. So it is useless then. Okay, it is absolutely useless. Can you see what I'm trying to do, though? I don't know if I'm doing it wrong. I'm trying to take advantage of the operating system when I can. Otherwise, I'm just going to make a spin loop. I don't want to do a spin lock. Sorry, I don't want to do a spin lock because reasons. And oh no, get rid of that code. That was just stupid. That was me thinking about, you know what you could do, Bill? And I'm like, yeah, that's stupid. Yeah, it's Am I going to have to just do a spin lock and say sorry for the performance problems? It does look like that, doesn't it? It does look like that. So let's just copy this select statement and see if we can re-implement this in Odin. Because we could get these things are pretty damn cool. I have to admit, that is pretty damn cool what I've just... It's kind of like a condition variable, but it's a byte wide. Just using the wait on address thing. That is pretty cool, but we're going to get the... Where was it? Where was my Lucas numbers here? Yeah, here's the Lucas numbers. This thing's a entire mess, I know it is, but shush. So the Lucas numbers, we're going to do an infinite for loop this time. And we're going to have two different channels. Both of them are going to be ints. One's going to be the channel, and then the other one's going to be quit. It's going to be for select here, and then we're going to have a select statement. So this has to be a blocking one. So in here, oops, channel, select, and both of them are going to be select to receive. I'm going to call it, this is what the code I did. So this is going to be non-blocking, and that one's going to be non-blocking as well. Non-blocking, and then the other one's going to be blocking. I'm going to be very clear in our language, okay? So if the count is equal to 0, then we could do the non-blocking case here, can't we? But we're going to just copy it again. If the count is 0, we're going to wait for any of them. Okay? And the only way I don't want to wait for the first one. I just want to wait for any of them. And that's where things go a little bit weird. So we could... I don't want to wait for like a millisecond, because that's too slow still. Anyone got any ideas? So what I'm going to do here is just put this in. Let's do a switch statement that does this, and then the channels I'm putting in are C and quit. So case 0 and 1. In the 1 case, we're going to do that. In the 2 case, I'm going to do this and write quit and return. Yeah? We can get rid of the close now. And then we're going to have two different channels. We're going to have the quit channel. This is not going to be buffered, neither is that. We're then going to have a thread here of the different parameters. So just to keep this a little bit cleaner, so we're going to have C sync channel int. It's just, I know it sounds like, why are you passing them there? Just make it clearer what's going on. And then we can just go init, like so. Screw the destruction for the time being. I really couldn't give a damn. So for I is in 10, yeah. We're going to then print, yeah, sync channel receive. I'm going to receive from the normal channel, and then when we're done, we're going to send to the quit, just a number, any number would work, and then we're going to do this thing like so. And now it should be blocking. Well, it won't. We're not going to compile because I don't want to break things. So what I'm going to do is just put this into check mode. And then it says, okay, that's sync.blocking. Okay. So if it is blocking, we're going to just do a literal loop across forever. And then I'm just going to put a loop in here. And then we're going to just redo the entire thing like so, just to get the same thing again. And then I'm just going to put assert. No, we're going to just do for count equals 0. I'm just going to do that. And then we need to, so we've got thread in here, haven't I? And then yield. Thread. I've got the yield, which is the switch to thread. Like there should be probably a thread yield in the synchronizer as well. Probably. Thread yield. Like what did I do in thread Unix? The yield is Unix. Schedule yield. So if I go to the sync units, is there a Unix in there? Yeah. So let's call that thread yield. So it seems like I'm just putting them in two different places now, but no, it makes sense for what I'm trying to do, which is the channel crap. We're going to put a thread yield here, as well as in there. We're then going to put into every single channel, we're going to break out of that loop. Yes, I know how bad this is. Shush. And then we can then go through this. We yield the thread again. And then that should be okay. But just to make sure, what I'm going to do is, like I do with everything I've been doing here, is time sleep 3 time seconds. After 3 seconds, eprintf failure, and then os exit number 1, and then let's do run. It says failure, which is good, which means it was blocked there until anything was happening. So if the len of channels equals 0, what I'm just going to do, it should be blocking forever technically. So we can just do this. As silly as that looks, it'll work. Well, I shouldn't do that. In the case of len channels equals 1, so we should probably make this into a switch statement, because then it'd be we can do some of the edge cases. So we have, and then case of 1, if there's only 1 that's being passed, then we know yeah, so what I'm going to do here, which is what I technically need to do, is if, no, let's just do that. Just keep it simple for the time being, okay? We're not doing edge case, let's just do them normally, which is still failing. And I'm guessing it's going to be here. And there's no fumt in here because I've got a test. Okay, so no, it doesn't get into here. It should. This is the blocking one, isn't it, for the receivers? So we'll go to here. And I should get a here. And I should get an infinite amount of heres as well. Just close that down. But the thing is, it never says it can receive, so I'm going to make sure nothing else is blocking it, okay? So, running a thread to receive, and then it's coming along here. And am I actually doing this correctly? No, I'm not. Shit, no, I'm not, because I'm actually checking to see if either of them are able to receive or send, not just one can receive and one can send. Oh, that's why it doesn't work. Damn it, you moron, you're just trying to copy things from the Go. Oh. You mean completion ports? Maybe. Like, can you understand what I'm trying to do? I'm just trying to wait for multiple things, at least one of them. I don't even have to wait for all of them. I just need to wait for any of them which are become available. Just start. Just stop. Just don't. That's my case. Okay? Does that make sense? Like, it's as simple as that is all I'm wanting to do. Because otherwise I'm just going to have an infinite loop and just checking it. Because otherwise the actual behavior which I would do if I was just being lazy, which people would laugh at, but no, really, what I would literally do is this, and then sync, can we send to, so channel can send, and can I send to the X? If I can, we're going to just do this. So this is a non-blocking case, of course. In the case of channel can receive, which is quit, then what we're going to do is just receive. So sync channel receive quit, and then return. And then in here, we're going to do, say, thread yield, or sync thread yield, whichever. And then it fails. It's failing then. It's getting locked in some place. Yeah, it's one of those where you go like, look, this is how it shouldn't be difficult conceptually, because, well, it's just because you're trying to have a choice between multiple things, and that's where the logic happens at least. Right, sorry. And then, yeah, you're trying to... What's the best way of putting point? Yeah, you're trying to do all that, and it just doesn't work. So... Because clearly it's getting locked somewhere. Now, the question is, where is it getting locked? Is it also just because, like, can receive and stuff is not in the right place? And can send... Yeah, you see, the problem is you need some more storage for the condition variables. So... Which I could do, but it shouldn't be this complicated is what I'm saying. Because especially with the Go's approach, it has like a futex effectively. So it is actually getting through this. But I want to know where it blocks. Because it's blocking somewhere. Well, it's clearly blocking here. But it says it's trying to receive. But this is being called. And then it's checking to see if it can send, else it can't. Yeah, and if it can't, what I'm going to do here is time sleep, time millisecond. And I'm just going to sleep for a millisecond. And then it fails. So what I'm then going to do is on each iteration, let's say don't sleep, let's just sleep for 100 milliseconds actually, because then it can just do all this crap. Then we can do sync channel can send, which is C. So sync channel can receive, which is quit. And then it says false forever until it quits. So I'm trying to think. I think I've probably got the logic for these can send and can waits wrong anyway. So let's see. Have I got them right? Because I don't actually. Okay, so we do a mutex lock here. If it's closed, you cannot send to it. If it's nil, you cannot send to it. If its capacity is greater than 0, then we need to check to see if it's ready, not ready, you can send to it, or if the len equals 0, you can send to it. Yeah. Okay. Now with the can you receive? Well, that's the correct logic already. This one was just you needed to check to see if it was either ready or the length was equal to 0. Let's just say it's less than equal to 1, but it's the same effectively. So if I get rid of this, it's now crashing on me. Interesting. Oh no, that's fine because, whoops. And then it gets to here. Oh, it's because of the condition. Can you see what the problem is? Like, it's getting to the case where it can receive, it can send, but then that one is valid. Yeah, only if, sorry, that's the case. If both of them are correct. Wait, is that correct? No. You might be actually right there, actually. If it's either ready or not? There we go, better. Yeah, so this is where... at the moment, this is what I've got here is technically a deterministic choice. Yeah, you're right, it is if it's ready. Bloody hell, why did I do a not? You're right, but it's just... This is effectively the deterministic choice rather than the non-deterministic choice. And I don't particularly like them, but... yeah, it works. I mean, that's showing you like a select statement, effectively, in Odin. And it's working as I expect. So if I did this to another, let's say, 20 of them, that's fine. And we can probably get rid of that as well, and it will work magically. It's just a spin lock at the moment. Deterministic non-blocking thing. And yay, I guess. So this is... Ooh. It's... I'd rather have the non-deterministic case, just because then it's better for load balance. Because that means you don't ever have a case when it could just go bloop. This won't ever lock because the other case is not ready. Is it, you need to have it ready? Sorry, is it both actually I need? Yeah, it's both ready and length is that. For this one, you can send to it. You do need to check to see if it's ready, don't you? In both cases, even if it's buffered. So if I just made this buffered, yeah. So the logic was correct. You need to check to see if it's both ready and it's that. Okay, that was correct. Sorry, I had to figure that out in my head. Because checking to see if it's received is, you probably need to see if it's not ready. And then the length is greater than 0. So it's the opposite, or is it both? Opposite of... No, I was right. It has to be not ready. And then... That's correct. Okay, thank you. I got the logic the wrong way around then. That was lucky, and that made sense. Yay! So I'm pretty happy with that little example of a select statement. You've technically got the default case as well. So if we wanted to do a default case, which was a bit cleaner, to be honest with you, than this. Because I might just... I know it sounds daft. I might just get rid of this case for the time... yeah, I'll get rid of this case for the time being. And keep them. They're better names. Yeah, I just need the edge case for when it's 0. That's fine. Just put it in anyway. So let's try a little bit more of a complicated case. So one of them is going to be a ticker, and one of them is going to be a only do it after a certain amount of time. Yeah? So we're going to do this. Keep that thing in case there. So I'm just going to copy and paste this again. Yeah, we can ignore all this crap for the time being. And we can... We'll say got a ticker. Yeah. Sync channel. We'll just say it's a boolean. There's a channel in there. And actually we could just say channels. Channel make for the partic, and then the boom. I'm just copying it again from the go, just to keep it simple. Because then, this is the deadly case. This one is going to be data, raw data. Tick. Run with data. He needs closures, really. So tick is going to have one every so on. So sleep, we'll say every millisecond, and then we can send some data to it. So time. So we can sync channel, send, and say it's just a boolean. That's our ticker. And then tick, in this case, is going to be sync channel int, but we're going to cast to it from the data, like so, to get the actual data structure. Done. this is the after. And then after, was it 500 in the example? It all works. So then we've got an infinite loop. We've got a switch statement. In the sync channel can receive, we got the tick, we got the boom, and then we've got the default. So in the default, I'm just going to just do a default print here, and then sleep for 50 milliseconds. That's all I'm going to do. In the boom case, I'm just going to write boom goes the dynamite, or just like that, and then tick for the rest. Oops. Oh, did I say, wait, I'm not making them ints, they're booleans, whoops. Tick, 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 tick. And I should fail after a few seconds. That's seriously a hell of a lot. That's because I don't actually check to see if I can receive it. So, if I can receive, then I need to get it, sorry. Sync channel receive tick, like so. Same with the boom. Oops, I put the semicolon there. Tick, 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 tick. Failure. Interesting, that is. That really is interesting, because I would have got the boom there. Oh, that's because you idiot, Bill. Yeah, I'm a moron. Closures would have helped, but look. Tick, 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 boom. Tick, 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 boom. Look how actually that works. So it's worked out pretty well here in this case. So I'm pretty happy with that. Can receive and ignore. And then raw channel. Can I just pretend to receive? That's the thing. So I don't want to put a message in there, if that makes any sense. Oh no, I can do. I can just say message of like type T. Raw, raw channel receive. No, let's just put the actual receive in there. Like so. Like so that, and then what you can do here. If you can send, then send. Only send if you've actually got the message. Yeah. So if you can send, return false and return true. And then if you can send, send. That's how simple it is. So in these cases, no, that's technically a try send, isn't it? Let's just try receiving, actually. But I don't want to care. I don't actually care about anything else. So I just want to try receive. Oh, okay, that makes more sense. So I can. It's a much better syntax now. So I'm going to channel try receive ignore. Same with that, because I don't actually care about the variable. Does that make sense? Yeah. Okay. And the same with this case here. This is, I'm trying to try receive ignore. This one is I'm going to try send the X. Okay, this is already starting to look pretty damn good, isn't it? So the only problem here is we aren't doing any blocking, and we're just doing a yield every single time. So, but in general, that actually, oh, it's not doing the, whoops, it's because I didn't put the yield in there, is there? Yeah. It's because I need the yield here rather than the default case. I always need to yield on every single case. How does that look to people? I'm actually getting a deterministic choice select statement thing that's non-blocking, and it looks pretty. Because this is a try, receive, ignore. I don't like the name. Can anyone think of a better name? Because you've got try send, and it does a boolean, and then you've got try receive. But you want to try receive and oh no, let's try and receive pointer. Yeah, so we're now passing it as a pointer. That makes more sense. Yeah, because then you can also just go like so. No, you don't need to put a maybe variable in there. You can just put a nil. And message doesn't equal nil. Yeah, there's no other. You don't need a stupid do maybes, to be honest with you. I didn't like the ignore bit. If that makes any sense. I just didn't. Let's do that. And now it works. And he's getting clearer now, at least. Are people understanding what I'm trying to do? The only one I want to do is I want to get... If someone can think of an elegant way of doing this, seriously, like a really elegant way, that... Oh, actually, I think I can think of an elegant way. That's the thing. I think the elegant way is you do just use the stack variable in storage, don't you? And then in your channels, you actually have a pointer to that stack variable, which uses that new thing, like wait on address. And then, oh, that makes perfect sense now. Oh, that makes sense. Oh, something like that. No, it doesn't. No, it doesn't. Still can't do that. Damn. No, that's what happens when you get tiredness. I'm going to stop in a few minutes anyway. Thanks for all watching anyway, but yeah. Because we've been going now for like 2 hours straight. Wow, 2 hours. Just me talking nonsense. But yeah, I'm pretty happy with what we've got so far with channels. And I'm trying to get the API to work a bit better anyway. So yeah, I probably should also put a location variable in there. So call location, location. That's just because then you've got better error messages when it panics. That's the whole point. So we're checking to see if it can receive, and what does I need to do the... It's going to try, and it's going to do check to see if it's the ready and the len, because that's true, and then if it's okay, that does that. I'm doing a try lock as well, because it could just fail to try the lock, but that's okay, that makes perfect sense now. Oh, and that was... I don't need that actually, can I? Oh, now it's failing. What did I change? So it's sometimes failing now, and it's not getting there. Ooh, that's weird. That really is weird. Ooh, why does that fail? Because it's probably locking on one of them, isn't it? Like, it's probably locking here, isn't it? On the try send. Which, looking at this... I haven't handled the actual case here, have I? So, if it's blocking, and if it's non-blocking, then I'm going to return false. And I'll also unlock there as well. And that makes more sense now why it was failing. Okay, this is the thing about concurrency. You're trying to do the primitives and you're just not using someone's library or anything like that. You have to remember every single case of how things could go wrong. Yeah, that makes more sense now what's gone wrong. And I don't know if I like this API. But it is working. It's just a switch statement. There's nothing special about it anymore. But it is deterministic, which is not necessarily what you want, but yeah. Okay, so for the people who are still watching, because there's a few people watching still, a few dozen. So, how's everybody doing? Before I go, has this talk made sense to people? What I've been doing today? Because I've just been experimenting. This is what I've been doing in my free time when I've had it. Because it's been fun. To be honest with you, it has really actually been fun. And they just allow 100's a bit too much, so let's go to 90. That'll look like it'd be fine, yeah. So all Lucas numbers up to a 90. Oh wow. We could just do the... Let's do previous as 1. Let's call that X. X previous equals X. And then we could do f64 of X divided by f64 of previous. And then you can see do a printf actually. Let's just do %d and percent. Let's do 9f. New line. Look at that. It actually converges on the number really, really quickly. So let's go to 15 decimal places. And look, it gets to the number very, 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 very quickly with the Lucas numbers. It gets to it. Let's just put I in there as well. After how many iterations does it actually converge? After 40. If we change this to the Fibonacci numbers, it converges after about 40 as well. So it's no faster. Okay, it looked like it was getting there better. And it is kind of the truncation as well. But that's pretty cool. Okay, hopefully that's been enjoyable to watch. But yeah. Yeah, I'm just doing it on no, I should have done it there, you're right. It should be afterwards. It shouldn't be elsewhere. So it should be there. It shouldn't be after you've unlocked. It should be whilst you're locked. Yeah, sorry, that's a bug as well. Thank you for telling me. I don't want to do the convergence there for the golden ratio. Let's just do that. That's not bad, in my opinion. Let's just test some of the other code. They're all deterministic. It doesn't really... You've got one on lock. No, I didn't. Oh, it's there. Shit, you're right. Thank you. The weight group thing was pretty cool as well. That was the other thing we tried as well. We tried this thing. Weight group. Well, I tried this. I shouldn't say you. Tried this thing here, which is with the closing of the thing. I tried the go approach with the summing thingamabob, and it works. And you can see it is going to be, look, you can see this flopping, so it is changing between the two of them. This thing was just me doing channels and seeing if buffer channels worked. And then there's also this thing here was me pretending to do things correctly. But now, let's do the message string. And actually I can just put message string in there. Aha, look at that, true. Try receive pointer message. And then we could do the same thing here, but for output 2. Else we're going to sleep. We're going to ignore all that. And there we go. So that worked as well. I'm pretty happy with this, if I don't say myself. I want to see if we can actually make something decent with these threads, channels, thingy-bobs, later on. But yeah, it's fine. I'm also, the run with data is a bit... To be, I know no one else is using it yet, just me. But it's this putting the data afterwards looks a bit wrong. When I say wrong, it's just it doesn't look pretty. So if I go for thread and then run with data, if I put the data here, it's probably a hell of a lot cleaner now putting it here, because then you know exactly data is going in. So if we look at another run with data, you can then actually see what's going on. Like that. And then we can do the same thing again. Yeah, I just think it's probably a little bit... Yeah, it's probably cleaner what goes on with this approach, yeah. Run with data, with a data pointer at the start. User index, I just do this. Because I'm also asserting that the user index size is your int pointer, it's the same. That's okay, I got a once thing here. This is in a different function, just for procedure, because it's... that's just to help the optimizer, to be honest with you. That's all that exists for. It's just to make it so it doesn't really... It doesn't... Not to inline it, but it just helps it knows that, okay, this shouldn't be in there. That's cleaner now. I do hate writing this because of how verbose it is. Can I do that? No. Transmute to raw. No, I could do. I'm not just going to do pointers. Just pass the pointers all the time. Okay, so that looks like that. That looks quite pretty good to me. We can then do this. So we'll go server 1, server 2, from server 1, from server 2. And you can see that they started at different times and they'll end at different times. Look, you can see that it is concurrent. That thing works as well, very well. I think all my demos are working probably fine now. Let's just go for this pretty one here, which has now got the trisync. It's not ignore anymore, it's pointer, and it's got a nil in there. We just don't give a damn about what that is. And there you go. Isn't that wonderful? Seriously. That works. Because I'm just... Yeah, I'm just trying to think this through, but I think that makes sense what I'm doing, because it all looks kind of pretty. You got tick, 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 tick. Let's just make this a bit longer so it looks a bit cooler while we're doing it. Boom. Okay, so... And look, you can see the concurrency thing is this actually didn't work exactly aligned. Like there's some delay in the ticks. And also, the question is, do you want to tick initially? Yeah, you can see it's concurrent because the ticks don't actually line up. That's pretty cool when you realise it. But yeah, you do want the tick. You want to sleep then tick. But yeah, you can see they don't actually line up. That's just cool. That's concurrency for you, man. Concurrency. And then this is just... It doesn't care. So, last question before I go, people say they can probably help me out here, is you can, you can do the try, send, receive pointer thing here, but my question is, even though you can receive, I don't think this is a nice name for it, because I kind of want both. But I don't think the name pointer makes nice sense. It's like try receive. Yeah, try receive pointer. It's not very clear. I don't like it. The other thing I don't know is it should have just called it chan rather than channel, because it's a bit long. I know it sounds like it's just a bit long, and I'm like, yeah, it is. Yeah, you can have too long, right? And then like there you go, chan make. You got chan try that. Just keep channel for the time being. Who cares? It's clearer. But yeah, I just know it's just the name that's putting me off. I do like this because now we've got a select statement which is proc overload. I know it won't work. Well, it would work, but it wouldn't look good. Because the problem is you would have to... We could try it. Honestly, we could just try it. Try value, and then we've got... So yeah, you're probably right with the proc overload here. And then with this... Yeah, but it's now going at me and going, it's got ambiguous parameters. Because it's not actually sure what you're meant to be giving it. And that's correct. That's why I didn't like... Yeah, I like that. Let's just go with pointer. Screw it, it's fine. I'm going to stop now because this has been wonderful and now this is working. And you see my little experiments with CSP as I go along. I'll try something a little bit more complicated than just literally copying the Go demos, what they've got. Especially since you can do a hell of a lot more with this concurrency. And I've added loads more primitives. So if people are talking about stuff here, if I go to the sync stuff, I got the atomics. I might remove the atomics just because I think the intrinsics are actually just clearer. They're like just easier to use. They're clearer, and I might just literally just get rid of all this crap. Just use the atomic, like the intrinsics, and I may just alias them in here if you do need to use them. But yeah, I've got a weight barrier in here. I've got a barrier group which is pretty simple. So a barrier is you enabling multiple threads to synchronize the beginning of some computation. So what it means is, right, we're going to synchronize at this point here. So we're going to wait for everyone to go. And then when everyone has got there, just everyone sets off again. So it's a synchronization point for the threads. That's all it is. That's what a barrier does. So it's condition variable mutex. And then I've got the index and generation stuff and thread count. How many threads you want to deal with as well. Now what else I've got is a weight group, which is essentially the same as a barrier. But it's instead of how many threads there are uphand, you can add them as you go along. And what's the other thing as well? Yeah, it is similar to a barrier, but it is more of it adds and then dones and add and dones. It's not just say, hey, this is where we want to stop. You have to be a bit more manual about it. So depending on which one you prefer, you can do either. I might improve this logic a bit more. Yeah, because I was doing the thing there, sign out. This was just shit. I mean, it's like 10 minutes. With some nice little message, but 10 minutes. What else did I add? Channels, yeah, you know channels now. There's ticket mutexes in here. There's CPU relax. Wait, have I been using the wrong thing when I said thread yield? Did I mean, not being rude, did I actually mean CPU relax? Is what I actually meant. Yeah, it is, isn't it? Shit. Wow, that's how tired I am. Someone's going to tell me in the comments, you've done something wrong, you shouldn't have done thread yield. What you meant to do was CPU relax, you moron. And I'm like, yes, you are correct. So what are you going to do about it? You're not going to see it because I'm just going to thread. Let's do, no, I've got that. Whatever. You're not going to see it, but shh, go sleep. So sleep. Go away. And then, what else did I add? Did I add anything else? You got benephores in here as well, which I added, which is just a semaphore and a counter. I will say that semaphores are some of the most useless things in the world. But yeah, I was trying to use the proper new ones. Like you have to do an atomic add. It's an acquire, a can't exchange attributes and acquire, and then this is a subject release. And I was trying to do it correctly. I think I've got it correct. I hope. But a benephore, yeah, is pretty much just whatever. So I think we're gonna go now. Good night. Thank you all for watching, and it is now Thursday. That's what happens when you go for this long. The day of it's Odin's son's day, Thursday. And now, good night.